Assalamu alaikum friends. Today we're going to study the unit 1 Thermodynamics. We will be covering all the aspects of the topic thermodynamics that is a part of our course and also the part of my presentation for Principles of Chemistry 2. This is a detailed video about the basics of thermodynamics and the introduction. It will be consisting of 4 parts. This is the first part. Let's get started. You might have heard about thermodynamics and its working in different fields like physics and chemistry, but you do not know the literal meaning of thermodynamics. Let's focus on the basics of thermodynamics and all the aspects covering the introduction to the thermodynamics. So, the introduction to thermodynamics is based on the meaning of thermodynamics. Thermo means heat, and dynamics means the study of motion. Both of these words combine to form thermodynamics, this field of physics or chemistry which involves heat and motion, in which we study the motion along with the heat. So, what are the components or the necessities of a thermodynamic process and why this thermodynamic process occurs and what are the components of this process? So, basically, the components or the necessities of a thermodynamic process are based on system and surroundings. Now, we will know that what are system and what is a surrounding. Now, if we talk about the reason why chemical reactions occur, the simple answer is that chemical reactions occur because the system or the molecules or anything that wants to achieve stability. For a reaction to take place spontaneously, the final products of the reaction must be more stable than the starting reactants. So, to attain the stability, the substances perform chemical reactions. So, talking about the components of a thermodynamical process, firstly, we need to differentiate between two things, which are the system and the surroundings. System is the part under study or investigation, and the surroundings is the area that or the things except the system, which is under study. To perform a logical reaction, we need to understand all the processes taking place during a chemical reaction, all the heat losses, and all the things. So, we need to differentiate between system and surrounding. System is anything under study, and surrounding can also be known as the universe. So there is a thing between these two things, system and surrounding. It is the boundary, and there are the types of boundaries. Different types of boundaries include the real boundary and the imaginary boundary. And the other two are the rigid boundary or the flexible boundary. Mostly in the processes of thermodynamical processes, we take the rigid boundary and the real boundaries. So, what did we understand? That there is a system, a surrounding, and a boundary to perform a thermodynamic process. Now, heading towards the next concept, which is the two other types or kinds of boundaries. So, studying the thermodynamics, we must know the boundaries of a system and surrounding in terms of heat transfer. If the system could be truly isolated from its surroundings so that no energy transfer could occur between them, then the total energy E of the system would be conserved and remain constant throughout the reaction. That satisfies the first law of thermodynamics. So a boundary can be diathermic or adiabatic. So what are these two words, diathermic and adiabatic? I'll tell you what are these words and what are the meaning and the practical application of these two words. So, diathermic is the type of boundary between the system and the surroundings from which heat transfer can occur. That means that the boundary will be conductive and will allow the flow of heat. So, we're writing here is conductive boundary. Heat flow is easy. And the other one is adiabatic, in which the heat flow is not easy or it is permitted, which means the heat cannot flow because it is a diabatic boundary. There is an insulator between the system and the surroundings. So in the diathermic example, an open vessel is a diathermic example, diathermic boundary, because there is no cover over the vessel. But in a diabatic, surroundings and the system have a lock, like there is no heat flow. Neither the mass nor the energy can leave the vessel. If the heat flow occurs, then the heat will be transferred from higher temperature to the lower temperature, and temperature will eventually become same. So in the adiabatic boundaries, the heat flow does not occur to maintain the temperature between the two things like system and the surrounding. So it means that in a diabatic system, delta Q is equal to 0, which is the heat transfer, total heat transfer. So a system can be of three types: open system, closed system, and isolated system. Now you might confuse the two terms, closed and isolated. For your information, closed and isolated are two different terms. Talking about the open system has mass exchange and energy exchange. Both can happen, but in a closed system, it cannot. But in a closed system, mass cannot be transferred, but the energy exchange is possible. Then how is the energy exchange possible inside a closed system? It can occur by two means, which is the heat or the work, in the two forms. Let me explain you this concept after telling you about the isolated system. So we know that in a closed system, mass cannot be transferred, but energy exchange is possible. And in isolated system, both of them are not possible, neither mass nor energy. So talking about the closed system, taking an example of a closed vessel with a piston which is movable. So we see that it is an adiabatic boundary. There is an insulator, so the heat cannot be exchanged between the system and the surroundings, but the energy change can occur. There is no mass change, but the energy change can be occurred in the form of work. When the piston moves up and down, the energy change occurs. So we see that inside a closed system, mass cannot be exchanged, but energy change is possible. But in the adiabatic and isolated system, no energy change nor the mass change can be possible. So we can say the system which is isolated is in complete isolation, and there is no mass exchange, no energy exchange, neither in the form of heat nor in the form of work. Let's talk about the next basic concept of thermodynamic properties, which are the extensive properties and the intensive properties. I'll tell you what is the meaning of extensive and intensive properties and explain it in detail. So, thermodynamic properties include extensive and intensive properties. So you might be wondering what are the extensive and intensive properties. So the extensive properties are the properties which depend upon the amount of matter or the size of the system, which directly means or indirectly means the amount of matter, because when the size of the system increases or the vessel increases, the amount of matter increases. So extensive properties are the properties that are affected by the change in amount of matter or size of the system or the sample. For example, mass, volume, And we can understand that by a simple example, that if a glass has water, if we have a glass of water, the water is lesser than a jug of water. So it differs with the amount of matter. So this property, with the properties which are changing with the amount of matter or size of the system, which is the jug or the glass, we will call them extensive properties. And the other ones are which move counterly, which are not dependent on the amount of or the size of the sample, are known as intensive properties. For example, the refractive index and the specific heat capacity. They do not depend upon the size of the sample. That is why they're known as intensive properties. So the next one is the state variables. What are the state variables? So talking about the state variables are, by the name of the thing, you can understand that state variable will be meaning something related to the state. State variables are also known as state function, state parameters, so don't get confused between these three terms. Anywhere if state functions comes, state parameter comes, we know that it is known as state variables. So one more thing which I'm going to tell you is that when extensive properties are over the extensive properties, they both are cancelled out and they become intensive properties. For example, in enthalpy, entropy, and Gibbs free energy or the internal energy, all of these terms are the extensive properties. A state variable is one of the set of variables that are used to describe the mathematical state of a dynamical system. Intuitively, the state of a system describes enough about the system to determine its future behavior in the absence of any external forces affecting the system. Simply, we say that the state variables are the variables which define the state. If they are changed, the state will change. For example, in a thermodynamic system, a state variable is an independent variable of a state function like internal energy, enthalpy, entropy. Examples include temperature, pressure, and volume. Heat and work are not state functions. We will be discussing it in the next video. So if pressure, volume of a gas or the temperature of a gas changes, we know that the state of the gas changes. So these are the state variables of a gas. We also know that a state variable is a variable that depends only on the final and initial state of a system and not on the path connecting the two states, which means that internal energy and enthalpy are the examples, perfect examples of the state functions